So some other problems relate to inconsistent SIP signaling delivery. Basically, am I getting all the SIP messages delivered from one side of the network to the other? So one of the things that shows up kind of remarkably frequently is problems related to maximum transfer unit. So if the SIP is larger than the path MTU size, and especially this happens with UDP, then the packet may be dropped silently. You may get no hints. And sometimes this can happen. You can solve this with TCP, but sometimes this happens when the SIP message just gets a little too big and it's not fragmented as it should be by the routers along the path, and so the packet ultimately gets discarded. We've seen this in MPLS network implementations where you'll have Ethernet switches that are capable of doing MPLS tagging, but they're not capable of doing IP fragmentation. And so if the packets are over a certain size, they can grow. Now, one workaround for this would be to use TCP. Like I said, potentially that can help. Another one is to reduce your MTU size on one of the endpoints that's having problems so that your MTU is small enough to be smaller than the path MTU. So if your path, let's say your Ethernet MTU is 1500 bytes, but somewhere along the path, you've got a limitation of 1480 bytes, then you may be able to adjust the MTU on one end or the other to down to 1480. And without making a very big change, you may be able to work around the problem. It's not a real fix to the problem, but it may basically makes your trunk short enough to go through the tunnel. The SIP ALG, sometimes you've got to disable SIP ALG on the firewall or NAT device, as I mentioned earlier on. Sometimes you've got symmetrical signaling problems where, like I mentioned with RTP, you expect to be able to send the audio to and from the same port numbers. You really want to do the same thing with SIP if you have any kind of firewalls or NAT involved. And so it's pretty common to look for that to see if you've got the same IPs and port numbers for SIP for signaling and for sending and receiving, specifically port numbers. SIP retransmissions can be a clue. If the path has high packet loss, SIP will be lost as well, and so you may be able to look for SIP retransmission. Sometimes your session border controller will give you status on that, or your application server or other SIP software will tell you how often it's having to retransmit, and that can be caused simply due to just high packet loss on the network link, due to a congested internet link or a poor quality, a bad Ethernet switch, or something of that nature. One of the most popular features for UCAS services, hosted PBX type services, is busy lamp field, or also called line state, but there's also a related feature, shared lines, line state monitoring, or shared call appearance. And with these, it's very important to use TCP instead of UDP because these features send very large SIP messages, and they will get fragmented, and enough fragmentation. The fragmentation can cause the packets to be ultimately dropped. And so by standard, you really want to use TCP when you have large SIP messages. I've heard of cases where entire major deployments kind of had a lot of problems because they had a lot of fragmentation, and the packets were getting lost. And so the perception was that the system just doesn't work because it can't recover for those lost packets. Sometimes you might have out of sync monitored line state. And this can happen when you've got SIP retransmission problems, but it's basically caused by the same root causes. We're not able to send through the SIP that needs to be sent. So the way this shows up is the user will have monitored lines on their phone, but they're showing the wrong status. They come in the morning and it shows that somebody's been on the phone overnight when in fact, they haven't been on the phone overnight. And so that the signaling problems can create that kind of symptom because we're not getting those follow-up notify messages to let us know what's been fixed or what the status of the line is.